What if I told you that one AI learned to beat humans at video games without being taught the rules, without seeing a single tutorial, and without any game-specific programming? Sounds impossible, right? But here's the crazy part. When researchers first tried building this system, it completely failed. The AI became unstable, its predictions exploded, and the mathematics behind it broke so badly that researchers gave the problem a terrifying name: the deadly Triad. Yet somehow, the solution to this problem became one of the most important breakthroughs in AI history and helped pave the way for the intelligent systems we use today. Here's how it happened. In classic reinforcement learning, an AI learns through trial and error. It explores the environment, performs actions, receives rewards, and slowly improves over time. But for something massive like Atari games, the number of possible screen combinations is basically infinite. You can't just store every situation in a giant table. The memory requirements would explode instantly. So researchers replaced those giant tables with deep neural networks. Instead of memorizing every possibility, the AI would estimate values using a neural network. Sounds smart, right? Except combining neural networks with reinforcement learning created a nightmare. When you combine three things, off-policy learning, bootstrapping, and function approximation, the AI becomes unstable. Its predictions start oscillating, the values diverge, and eventually the system completely fails to learn. This was the exact problem stopping reinforcement learning from scaling, until DeepMind discovered two breakthrough ideas that changed AI forever. The first was called experience replay. Normally, an AI learns frame by frame while playing a game, but consecutive frames are extremely similar, and that correlation confuses the neural network. So instead of learning immediately from recent gameplay, the AI stores every experience inside a giant replay buffer. Every action, every reward, every success, every mistake. Then, it randomly samples old experiences from the past and trains on them later. This breaks the chronological correlation and makes learning far more stable. And honestly, that one idea alone was genius. But the second breakthrough was even more important: fixed Q targets. In standard reinforcement learning, the AI constantly updates its own predictions while simultaneously trying to learn from them, which means the target keeps moving every second. Imagine trying to hit a bullseye while the bullseye itself is running away from you. That's exactly what was happening. So DeepMind introduced a simple but brilliant solution. They duplicated the neural network. One network continuously learns and updates itself, while the second network, called the target network, remains frozen. This creates a stable target for the AI to learn from. Then every few thousand steps, the frozen network updates, and the cycle repeats again. These two innovations transformed a broken theory into something revolutionary. By combining experience replay and fixed Q targets, DeepMind created the Deep Q network, or DQN. And suddenly, the same AI algorithm could master dozens of completely different games using the exact same settings. No game-specific programming, no handcrafted strategies, just learning. And it didn't merely play like humans. Sometimes, it discovered strategies humans had never even thought of. This moment completely changed AI history, because this shift from simple tabular learning to deep Q networks became the foundation for the intelligent AI agents we see today. But deep Q networks still had one major limitation. They learned by estimating the value of actions. In other words, they constantly asked, which move gives me the highest score? And for video games, that worked incredibly well. But researchers soon encountered a new challenge. What if an AI needs to make decisions in uncertain environments? What if it can't see the whole picture? And what if calculating a score for every possible action becomes impractical? Instead of learning values, what if the AI learned behavior directly? That question led to one of the most important ideas in modern AI: policy search, the same breakthrough that helps robots learn to walk, and eventually became a key ingredient behind how ChatGPT was trained. And honestly, the way it works is even more fascinating than deep Q networks. Because in the next video, we'll see how AI stopped learning values and started learning behavior itself.